Godot 4 is a really amazing game engine, and if you've decided to use the .NET version of Godot 4, this tutorial series is for you. Here, I'll be using C# in Godot 4 so that I can teach you the basics of how you can create a character controller. And we'll be going over the other stuff in later videos. But this video is this video, and I'm going to teach you a few things here. So now, I'm creating a scene with the character body 3D node. What's a node? A node is basically like, it has a set of functions related to it so that you can use it for functionality. The character body 3D, it's responsible for all motion in any given scene. The character body 3D node has this move and slide function that we'll be using later. And now I'm dropping a mesh instance 3D. You should too. The mesh instance 3D is a place where you can drop in your OBJ files so that you can actually have a model that's moving and not just your character body 3D. I'm creating a simplified convex collision sibling here so that I can add a collision shape 3D to the character body 3D. This is a very essential step, and if you don't do it, you're gonna get a lot of errors. You might get a lot of errors. I haven't tested that out. I created the pivot now because it will be a sort of a hinge joint for our camera to move around, rotate, and translate itself. And the name character2 is what I'm giving to my character here. Under the pivot, I'm adding the camera so that it can rotate around the pivot, right? So that's that. I'm gonna create a script for the pivot, and I'm gonna put the pivot at the center of our model so that it doesn't look very weird when we're turning around. I'm going to make the script called pivot2.cs, and for the character script, I'm going to make the character22.cs because apparently I've created a character2 before and it won't let me do it again. There we go. That's done. There's also going to be a script for the camera, and once we're done with that, we're going to open up Visual Studio Code. In case you're wondering how you can set up Visual Studio Code and manage it, just go over to my tutorial for that. Even if you don't have Visual Studio Code, that won't be a problem because the Godot inbuilt script editor is good enough. I'm using Visual Studio Code because I have a lot of trouble with patience, so I just let the Visual Studio Code thingy do the auto completion for me. So now, I'm gonna enter the script, character22. I'd suggest using the physics process function because it actually computes the physics inside it as well, which means that for every physics frame, your body will move instead of moving at every frame on your screen. So what I'm doing here is that I'm assigning velocity to the variable vel so that I don't have to type out the word velocity every single time. Now, to the variable impdir, which means input direction by the way, I'm creating a new vector3 which will absorb the inputs from the player. I'm using the getAccess function from the input singleton. What's a singleton? A singleton is something that's like a module, I would assume, and from the input singleton we're using the getAccess function. Here, as you see on the screen, the syntax is the negative action and the positive action. You can set this up in the Godot project settings. And for some reason when I recorded the video, I did not record this. Please forgive me. Go into the project settings and there'll be an option called input maps. Set up your input map however you'd like. And why is W a positive action while S is a negative action? That's a huge question, right? The answer is, it seems that negative Z, that axis, seems to be the direction that Godot counts as forward. That's very weird, right? So I'm gonna now create the direction. Why am I writing pivot here? You might think. Pivot.transform basis, actually. This is kind of wrong for now, but I'll explain it to you in the future so that you won't have to go through the struggle of understanding it right now, because it doesn't serve the function we need right now. It'll take a while, we'll get there. Yeah. I'm going to multiply the transform basis of the pivot, which means I'm going to make sure that whatever axis the pivot is turning around will be the axis our direction is going towards. I'm going to normalize the input direction vector, because when you're having two vectors, x and y, the resultant of the two vectors will be the direction the final product moves towards. I don't want all different directions and their combinations to have different speeds. I want them to have the same speed. That's why I've normalized it. So the velocity x is being multiplied by a speed variable here, and for some reason Visual Studio interpreted that as s byte, which I don't even know what an s byte is. So the velocity in the x direction will basically be the direction in the x direction multiplied by the speed. We haven't created the speed variable, mind you, but we will create it soon. I mean right now. We're going to use the export method. What this does is that it allows us to control the speed variable from our command center. Not our command center, but within our project inside Godot. So if we want to change the speed in the future, we can do that very easily inside the editor itself. I've now created a jump variable and a horizontal velocity variable. I'm writing it out because you need to know this. I'm going to just abbreviate it into HV. Got it? Now, we're going to take into account the velocity in the y direction. If the action pressed by the player is just pressed by the player, which this command indicates is the space bar, then the velocity in the y direction, that is the horizontal velocity, will be equal to the jump speed, which we declared earlier, And now, if it's not the horizontal space bar, else if it's not the space bar, and we are not on the floor, then the horizontal velocity will be the gravity itself, which means that velocity in the y direction, that is the horizontal velocity, will have the value of minus g. Like in our real life, we have the minus g as the value for gravity. Now I'm exporting the gravity variable so that it will be easier for us in the long run. I have messed it up once. Don't look at me like that if you're looking at me like that. Now the velocity in the y direction is equal to the horizontal velocity. Damn, that was easy, right? And now we're going to say that the inherent property velocity of our character body 3D is going to be velocity. We're now calling the move and slide function so that everything will actually work. But I haven't created the pivot, have I? So I'm gonna call a no3D PIV. Got it? Do it. Because without that, this is not going to work. Now I'm gonna create the pivot script first, because if I don't, it will be a waste of time. The public override void function is basically how you call the public override void method is basically how you call a function in Godot. Inside it has two parameters, the input event and the at event. We're now using the if statement to check if the event is input event mouse motion, if the player has moved the mouse relative to the last position, that is. And if they have, the variable mouse motion capital M will be equal to input event mouse motion Hello? Input event mouse motion. How I really took that much time here. I'm not gonna edit that out anyway because I have a lot of other things to do. Okay, so now we've got the mouse motion captured up in a nicely packed variable. If you don't know what rotation is an inherent property of any node that we're using right now, and it dictates what angle it will be rotated in the x, y, and z axes. The new vector 3 rotation will be rotation in the x-axis minus rotation in the y-axis. Why is that, you may ask me? The answer is along the lines of this statement. Okay, so when we're rotating an object around the y-axis, we don't say that we're rotating the x-axis. We say that the y-axis is the one that's being counted. So rotation along the y-axis doesn't necessarily mean that the y-axis is moving. It means the y-axis is rotating. You got that now? Now, in the public override void function, we have to do something. That is, we have to call the piv function and we have to get the node itself into the scene. We call this as making an instance in Godot. Why do we need to make an instance? It just makes things harder. I get your worry, but this is how things are done in C# inside Godot. I'm worried too. I don't show it out. And the getNode function is being assigned to the piv variable so that we can use the piv.transform basis here. And yeah, I can assure you that this actually works now. By the way, if you really think that your model isn't working and you did something wrong, just remember to set the speed, jump speed, and the gravity inside the editor. Okay, don't forget that. Now we're programming in the zoom in and zoom out ability for our camera. Okay, this is what we're doing. We're calling the input event function again, but this time we're going to be checking if the mouse button wheel is rotated inward or outward. For that, first we need to know if the event is an input event mouse button, which means, hey, has the player done anything with the mouse buttons? If the player hasn't, the answer is false and it doesn't proceed with the translation. But if the player has done it, it won't. It will, actually. Now we're creating a public float called sense, which is basically the sensitivity itself. And we're exporting it so that we don't have to take the trouble of getting into Visual Studio every time we want to change a little bit. So now the variable mouse button will be equal to the input event mouse button. Input event mouse button as an @event. We're saving that event as the input event mouse button type, and the variable mb is taking that in. So now the next thing we're going to do is this. Using the if statement, we're going to check if the mouse button dot button index, where's button index? Yeah, there we go. Button index is a mouse button, and that mouse button is wheel up. Then we'll make it do a specific thing. It's supposed to be wheel up. At this point of time, I think I wanted to sound idiotic, so I used wheel down. Yeah, there we go. It's supposed to be wheel up. Forgive me. I will change that at a later part of the video, but forgive me for now. So now we're going to use the property translate. Translate is basically going to do this. When you're going inward into the screen, it basically moves you in a certain direction using that thing. So now in godot, we know that the forward direction is the minus z-axis. So we need to create a new vector 3 for that, which I'm trying to do here. The variable here is up. The variable up will be equal to a new vector 3. A vector 3 is essentially a vector that's three-dimensional in nature, and the third dimension, which is the z-axis, is 1 in the negative direction. So the translate will be up times -1. If we do the cross product properly, we'll get this. -1 times sensitivity, I guess. What's cross product? These are all vector mathy stuff. You really don't want to know more vector math than you already know, because it will hurt your head if you learn too much vector math. I found that out in the very hard way. If the mouse button index is mouse button dot wheel down. I'm not using an if statement for this because if you obviously can't scroll down while you're also scrolling up. That's basically an impossibility. I've changed it to wheel up, as I've said earlier. And since that's an impossibility, the two conditions won't be checked for it once, so that we can minimize the lag, you know. I'm just duplicating that thing, and it's going very successfully here. And the second variable will not be called up, it will be called down. And here, we're gonna go outward from the z-axis, making the thingy move backward. So now we translated down times sensitivity, which would give us a magnitude of 1 times sensitivity into the screen, or outwards of the screen. Now our mushroom boy is ready for action. The mushroom boy can go inwards or outwards from the screen. He can move in the screen. He can do a lot of things. But in the sensitivity part of the thing, I tried to use global translate here. Please don't use global translate. This is not one of my glorious failures. It's in fact a really bad thing to do. It's gonna slow down your entire progress. Please don't do it. As you see here, I've decided that the sensitivity is 0.1, and I'm gonna check if it works. Before doing this, I changed it back to translate. I want you to change it to translate as well. A short mistake in this video won't take much time to rectify, right? So now, our mushroom boy can jump. Let's go. And in the character controller, I decided to not use the gravity even when the body is using the jump button, so that the physics look more real. Because the first time you jump off the floor, gravity will push you down very fast. And the next time you hit the jump button, you can jump higher. Like this, see? If you're trying to jump mid-air, you'll face a resistance, just like in real life. It'll look more realistic, trust me bro. And that's it. Subscribe to the channel if you want more content like this, that is. Thank you and bye.